Okay, this is improper integral, and you change like that. Limit when the b approaches to negative infinity of integral from b to 0 of dx over square root 3 minus x. Now we compute the antiderivative. The antiderivative is, look, antiderivative. Is equivalent. Antiderivative 3 minus x raised to the negative 1/2 dx. Now you change variable. Suppose que we declare 3 minus x equal u minus dx equal to u. Entonces integral u to the minus 1/2 minus du. And this is minus, this is u to the plus 1, que entonces positive half, divided by 1/2, que es the same multiplication by reciprocal que esto. Entonces es minus 2, actually, es minus 2, u is 3 minus x, raised to the half, evaluating between b and 0, okay, this is minus 2, okay, you evaluate the upper limit is 0 here, 0, this is radical 3, and b here is plus actually because it's double minus 2 radical 3 minus b. Now finally, you apply the limit. Limit when the b approaches to negative infinity of this expression gives 2 radical 3 minus 2 radical 3 minus b. Now this is a constant, stay the same, but this no. When you plug in here negative infinity is 3 minus negative infinity, double minus become positive, infinity plus 3 is infinity, square root infinity is infinity, and the answer is negative infinity, no? Because this is a constant. So the conclusion is this improper integral diverges. Okay? Okay, this is another improper integral, but in this case unbounded, because this function have a vertical asymptote at x equals 0. If you want to compute the limit, the integral from negative 2 to positive 3, actually the thing we're doing is compute this area. You separate this integral into 2 pieces. First one is from negative 2 to 0 minus, and you approach it to 0 to the left of this, plus integral from 0 plus, you approach it to 0 to the right, same. Okay, this is the idea. And the idea is compute back one by one this integral. Okay, let's do the first one. The first one is integral from negative 2 to 0 minus of dx over x squared. This is equivalent to, say, limit when the t approaches to 0 minus integral from negative 2 to t of the x to the minus 2 dx. The antiderivative is x to the minus 2 plus 1 es negative 1, entonces negative 1 over x, evaluate in between negative 2 and t. Entonces minus 1 over t plus 1 half, because there is negative here, with subtraction, but negative 2, it doesn't double negative become positive, no? Okay, now apply the limit. Apply the limit. The limit of this expression. Negative 1 over t plus 1 half. This is negative 1 over in 0 minus plus 1 half, no? This is 0 minus a number close to 0 but negative. Negative become positive, so this answer is infinity. Infinity plus 1 half is infinity, again diverge. Okay, I don't need to compute the second part, because see, at least the first part diverges. Yeah, the entire improper integral diverges. Okay, this integral is compound because involve unbounded in 0 and infinity integral. So we can compute it using this idea. Look, do you compute integral from 0 minus to one number in between the interval from 0 to infinity? I select 1, 2, 3, 4, 5, it doesn't matter. The answer is independent, totally independent of the number that you select. And another integral case like a limit when the b approaches to infinity of the integral from 0 to b dx over x squared. Let me try to do at least the first one. The first one is integral from 0 minus to 1 dx over x squared is equal to the limit when the a approaches to 0 minus of the integral from a to 1 dx over x squared. The antiderivative is minus 1 over x, evaluate in between a and 1. Entonces es negative 1 plus 1 over a. Now apply the limit. The limit when the a approaches to 0 minus of negative 1 plus 1 over a. Substitution, plug it in. It's minus 1 plus 1 over 0 minus. It's a negative 1, and this is minus infinity. Because it's positive divided by negative is negative infinity. The answer is negative infinity. One more time, diverge. This integral diverge. Have no value.